Hi guys, how are you? Today we are gonna continue how to design our pneumatic system. The topic of today is the pipe size calculation. So for this situation, I think up this situation. So remember that we actually have some part of our pneumatic package. We actually already select our compressor, our air receiver, dryer, and for the next week there's gonna be a video of for filters. So this is the package of the airflow. So for this situation that I invent, uh, this is your airflow. You have 30 links. If you know, since 0 until 16, the link 16, this is the distribution pipe. Since in the case for link 17 until link 30, this is just for service pipe. So the equation that we are gonna use to calculate the diameter, it's for this is a equation that it's a special equation for Darcy Weybridge, and you can find in Atlas Copco manuals. As you can see, you just need your pressure drop, your airflow, your internal pipe diameter, your length, and your absolute pressure, initial pressure. So that's all you need. So maybe you are asking where I put 7.5, 7.5, 21, 2.2. This is the data that we put in the first condition that we are selecting for reverter, 8 reverters, 4 drills, and 2 nut runners. So this is the 4 drills, 2 nut runners, and 8 reverter. I put this thinkings for I don't know, assembly line, something like that. So something that you know, this is the links. This is something that we are gonna consider this the flow. Why I put in this case 89.6 liter per second and now your airflow of the compressor, because you for this selection you should consider the summatory of all these of all the total flow for your pneumatic tool. So what does it mean? Is 7.5 plus 7.5 blah blah blah, blah until 2.2. That's the reason why you're gonna see the 89.6. And then why is 82.1? It's a difference because you have 89.6 for the 0 links, for link 1, link 2, but on the link 3 it's a different 89.6 minus 7.5, and because this is your demanding that this pneumatic tool is working, so you have a demand of airflow. So that's the reason why you should minus this, and that's how you are gonna continue for all the links. An exception for link 16 because it's just too close. Something that, so as you can see, I have this, no, 89.6, then minus 7.5, minus 7.5, there's 4 7.5, and now it's the 21, then 2.2. That's just for link 15, so just here. Then I put for link 17 7.5. Of maybe you are asking, so now because this is the demanding, this is just a service pipe, this is not for distribution, so you should consider the airflow for your pneumatic tool. So that's the reason why I put 7.5 for the drill, 221 for the nut runner, and the 2.2 for the reverter. So then for length I put whatever that I want, that I consider is gonna be okay. Remember that this is a situation, it's not a residual, it's just something that I put So I put 10, 10, 8, 5, 5, 8, you know. Here you can put whatever you want. In the case of pressure drop or delta, I find these numbers for there's a recommendation for Atlas Cafe that you can consider for service pipe, distribution pipe. In this case for cross riser. In this case we don't have that, but you can use it. So you know, distribution pipe and service pipe. Also, your working pressure, as you know, it's a 6 bar. This is also for our initial condition, but it's you can find this information if your pneumatic tool data sheet. So we have everything. So then we can calculate with this equation our diameter. In millimeter, we have 36.11, and this you are gonna continue with all until the length 30. So now you need your commercial number. So in this case is 1.5, 1.5, 1.5, 1 is the net superior. I don't know how to say it. The immediate superior number. That's the commercial. Now for this is for inches and this is in millimeter. And now you again calculate your drops. So it's the same. The same working pressure, the same length, the same flow, with the new in this case commercial diameter. And as you can see, your pressure drop, it's everything okay. All, and if you can see, it's better in this that the first condition that we considered. So we are okay. But now you should consider something more. And what does it mean? That I'm talking about velocity or your speed of flow. You have how you can know this. You have the dot of flow. In this case for your pneumatic tool. That's the for this part. As you can see, why I put 7.5 for link 0, because something that the first demand of comprimed air is the first pneumatic tool. If in this case the first drill, if I remember. So it's 7.5 liter per second is for this tool. So that's the reason why I put 7.5, 7.5, and you put in this case the same. You're gonna continue with the same methodology. I'm gonna assume it. How can I calculate the velocity or speed? With the same equation that you know, that you have your flow equal velocity multiply with the area. So you just consider the area of your commercial diameter and the flow you have. So you put this in meter per second. So in this case, but if you know here we have something interesting. We have 18.4, 41.4, 17.4, 60, and then we just up to 100. So some engineers like of some brands consider that, for example Hitachi, the maximum speed should be I think 10 or 12 meter per second, but there's a rule for API. In this case I don't remember the number, API 14, that tells you that the maximum speed could be 18.4. Why there's a rule in this case is just to have a better control of the turbulence of your flow. So, and also you should know that here you have 1.5, 1.5, 1.5, then you have 1 inches, 1 inches, 1 inch. So there's no all the distribution pipe is not the same diameter, and it should be. So that's the reason why I put, for this case we are okay, but for this no, and we continue in the distribution pipe. So that's the reason why I put 2 inches. This is in millimeter, but I put 2 inches for all the length from 0 in this case, since 0, sorry, from 16. So I put 2 inches, and then I put just 1 inches. There's an exception for, in this case, for the nut runners, because it's a great demand, but it's okay. So I calculate again the pressure drops, and we still continue in good condition. I calculate again the same way this velocity or the speed of the airflow with the same, but now I'm using the new commercial diameter. So you know, where we have problem before, now we are okay. 10.4, it's a good condition. So for this is also, look this, 18.4, and we are still in the rule of API, so we are okay. Something that maybe you're thinking that here you can have elbows, I don't know, valves. I've not put this because the only difference is that you're gonna add the length, and as you can see, there's an example. So, but the methodology is the same. Something that you should know, you with the same idea. If you have a very big distribution pipe system, I don't know if that correct that word, with a good length, so this distribution pipe can be considered like part of your air receiver. So what does it mean? If you calculate your volume average, you're gonna have a volume for your air receiver, then you can have your volume calculation and minus your internal volume for your distribution pipe. So if you select, I don't know, if you know that you need a receiver of 1000 liter, and then you know that your internal volume for your distribution pipe is, I don't know, is 200 liters, so you just need 8 liters for your air receiver. So that's better for you because you are saving money. So guys, that's all for this video. Remember, if you have any question, please do not hesitate to do it. I know my English is not the best, but I'm trying to do it with patience and joy. We are gonna continue okay. Thanks for everything and have a nice day. Bye bye.